Okay. Hi everyone. Today we will study more about, today we'll study about storage and storage options that are given to you by AWS, and what are the other different key components that you can use while working with storages. Okay. Let me quickly share my screen. You remember every time we were creating an EC2 instance, in that case we were having a root volume attached to all of our systems, right? That's where your operating system and other file system used to reside all the time, right? No. Okay. Okay, so I have couple of cool. Let me quickly share my screen, and then we'll start with the class. So when I'm creating an instance, if you see, okay, first thing that it asks for is name, correct? Then your operating system, which you want to, like the AMI. We'll study more about Amazon machine images a little later, but let's just consider this as an operating system or an image from which your machine or your this machine will be initiated. So this machine will be very similar to the AMI that we have configured here. Okay, not very similar, but exactly same. It's very similar to ISO files and other things that we use. This is the machine type. I'm creating a new key pair. Mhm. These are all the network profiles that we generally override. After this, like I hope you have noticed this before as well. Here in this, if you see, we have an option to configure the storage. Now the storage or the default storage that is configured here is elastic block storage, EBS volumes. Okay, so this is an EBS volume. There are different options that are given for EBS volumes. Let me explain you how we will go ahead by this. So when it goes to block storages, okay, this is basically used for attaching or designed for Amazon EC2 instances. So these blob storages are faster because um, they have high performance, they are fast, they are optimized, they are cost optimized actually, they are secure, and they do have some protection too. Okay, now there are two types basically: SSD based and HDD based. Now, HDD based is something that we are not considering right now. SSD based volumes is something that we are using here. If you see, these are all SSD based volumes, not HDD ones. HDDs are the cold storages. Okay, so we are not concerned about this. Okay, these two general purpose GP2 and GP3, they are of they are of general purpose ones. Okay, this provisioned IOPS has comparatively a higher input output, so it is going to be a bit faster than this one, but the cost is again higher. Okay, apart from that, this we have some magnetic one as well also available, but generally companies use either this one or this one. Okay, general purpose ones. Okay, so these are specifically built for being easy to use, highly scalable, high performance, and they are here to be attached to an EC2 instance and to become as a root device or a hard drive to a machine. Okay, they are not only used for EC2 instances, but they can be used for databases too. Okay, now let me configure and create one. So this is one type of file system. Okay, there are three. We will study two today, EBS and EFS. So EBS is basically elastic block storage. This is the default storage that is attached to an EC2 instance or an RDS and all. It is faster. It has a higher performance, and others. But there is only one restriction, that it can be only attached to one instance at a time. Okay, which means that if I've created the storage, it can be only attached to one instance at a time. Okay, so now if you see here, when I've launched an instance, just come to the storage block. If you see the storage block, it will specifically mention that it is an elastic block storage. This is your block storage. It is currently in attaching state, and this is of 8 GB as we mentioned. You can go ahead, create a volume 2. Okay, and like you can create an elastic block storage and attach it there, and you will be able to see it there, and then you can attach it and do whatever you want to do in that case. Okay, now next scenario, let's quickly check about the block storages here. Okay, how is it attached? Actually, I might have to close this window and reopen the window once again. It says permission denied. Let's just wait for a few minutes. My bad. Okay. Cool. Now, this storage that you see here is actually the root device, where all of your operating system and the other file system resides. Like your entire root resides here. Now, example, I already mentioned that why we need this is because in our previous class also I've mentioned why we need this is because, example, I have a machine. We have an operating system running here. We have one application running here. This application writes some certain set of files or something on this root device itself. So your operating system and your machine and your code, sorry, and your data resides in the same hard drive. When they reside in the same hard drive, there is only going to be one problem, that if your operating system gets corrupted for some reason, you will anyways compromise or lose your data too. So because they're interlinked with each other. Plus, there is always one more thing that you'll have to think about. Let me try it out too. Okay, and show you how it works. So example, I have two volumes here. Storage. This is my volume. Now, when I go here at this volume, Now I have increased this volume or modified this volume. When I modify this volume, it gets modified, but at the same time, since your operating system also resides here, okay, it is always a risky option. Example, my operating system resides here, my data resides here. My data is filling up my operating system. My data is filling up. I had this much space. This is my operating system and this is my data. Now my data is increasing. It comes to a stage that my entire disk is full. In that case, you will no longer be able to go in this operating system itself. Let me try it out, okay? So we have this much size. We have 6 GB available currently. Let me reduce it to. It's not allowing it to modify anymore. Mhm. Might have to stop the instance or take it in that way. Okay. Maybe you haven't noticed one thing. Here it is showing 10 GB, but this is still 7.9. That means only that is usable part. It did not actually get reflected. Let me reboot the system and then I'll try. I'm showing you certain thing. What I'm trying to do here is I'm trying to increase this volume, because tomorrow if your data is full, then what should I do? Here it shows size 10, but is it actually reflected here? Now it is reflected after reboot. Okay. Now your data is there. Now it is 10 GB and now it has increased. Earlier it was showing that it is increased but did not, until and unless you restart the system. Okay, then it will try to evaluate the stuff and take it forward from there. Okay, that's why it was not allowing you to modify it further, because the modification did not actually successfully happen before. Okay. Now second thing, when your data in your operating system resides at the same place, your data gets full. Okay, in that case there is a chance that your operating system is lost. Okay, you are not able to log in into the system, you are not able to perform any activity, because you need that buffer space to do it. You need some space to perform any activity on this operating system. That space itself is not there, which means that there is a possibility that you'll no longer be able to reach the system anymore. So what in that case, what you'll have to do is stop the system, attach it somewhere else, then copy the data and then give it back. So it's always better to have a separate disk or a device or separate volume and attach it to your system, rather than putting everything in your root device itself. Okay, so here I'm creating a simple volume. Size I'm reducing it to only 5 GB. I don't want full. Okay, now here I have created a volume. Now I want to attach it to an instance. Let's just give it a minute. Here it is asking you to detach a volume because it is already attached. Here we'll have to attach the volume. It's right now not in available state yet. It cannot be attached currently. What's the problem? Attach volume. It takes time, that's why. Okay. Device name, I'm going to give this one for now. Okay. You can give DEC, whichever you want to give, and attach the volume. Now we have attached the volume. We'll wait for a few minutes for it to come here. It is here now. Okay. Now to actually attach this volume or to be able to perform any activity to this volume, we will have to do, we'll have to mount it to the file system. Okay. Let me see. Okay. Um, just one second. I'm trying to get the end-to-end steps for you so that you guys can also go ahead and just follow that instances. Here we have already done LSBLK. We are creating a file system here. File FNS command to get information about the specific one. Okay. Okay, this is data. Correct. Okay. Now we will, this is getting all the information only for us yet. Nothing much. Okay. I'm going to use this. These are all the simple steps to perform, like to do this activity. There's nothing much we can do around this. Okay. If you get an error, do this. We already have this. Now we are going to just mount it up. Okay. We don't have partition yet, so we won't be able to perform this activity. This part we'll be only be performing this one. Can you see that? Now whenever you will go to slash data folder, it will actually be pointing to this. Okay. Now if you reboot this actually goes. So in this case we will have to go ahead and get and do some setup. But let me write something here. Just 1 minute. I'm just reiterating the fact as to what I've done. Okay, I did LSBLK to get the different different disks that I have attached. Okay, So there are two disks, this one and this one here in this case. Okay, LSBLK I have done. Okay, this will show you this is the default one and this is our new one. Okay, we have done XVDD. Okay, they have done XVDF. So that's the only difference. Okay, this will show you what type of specific file system and other things. Okay. We will also check the FS type here in this case. I think we should have changed the FS type to, let it be. MKFIS. This is giving file system to the disk. Okay. Make file system to the disk. Okay. This is creating the directory, simple directory in the folder, and this is mounting the directory there. Okay. Once we have mounted it, we can go ahead and create some files, file systems, and other things here in this. Now let me create one file. Simple file, nothing much. I don't know what I have written also. Let me write something. This is to test the file system attachment. Okay. Now what happens is next time whenever you reboot this, you cannot write. Okay. Let me write it via root. Okay, because we don't have access yet. This is to test EBS attachment. Done. So we will have a file here. Cool. Now let me reboot the system. What I'm trying to say here is, since we have manually mounted everything, okay, we did some commands, we mounted a few things and all of that. So after reboot, this mounting goes away. So we might have to remount it. Okay. If it goes away, still your data will be there in that file system. So whenever you will reattach it, you will get the data back. That's what I'm trying to mention here. So which means that whatever happens to the operating system and all will not affect the file system directly. Okay, because they are on different disks. Okay. Now another thing that happens usually in this case is it is a bit expensive process. Why? Because you are reading you are reading performing some activity in this disk, but we are writing it in another disk. Okay, that can take a few extra seconds, but it's all worth it. Okay, when I say mount, I should be able to get slash data mount, which I'm not able to get. Okay, LSBLK, it's still there, but now it's not mounted anymore, which is what was mentioned in this page as well, that if you don't attach or if you don't do FTAP settings, it will remove all the changes. Now, since it has removed all the changes, we are okay by that, because we would like to remount it too. Okay. You don't have to perform all of these actions. We can just go ahead and perform this mount action and see what it's trying to do. This was not even there. Okay. Now let me unmount it too. This is an option to unmount. Let me see what is the mount point. This is the mount point. This is the data. This is the information. Okay. Now, all of these pointers, okay, they are very, very important. Okay. But you will understand this only if you understand in depth of the file system and you understand the Linux and Linux operating systems too. Like deep dive into that. Okay. Now let me unmount this data point. Target is busy. Why? Because you are inside the data point. You have to come out. Then you can do it. Okay. Now if you do LSBLK, It's again out of the disk. Where is the test file? Where is the test file? Not there. Okay. Here we had a test file, right? In slash data, we had some test file. Now it's not there. Okay. Now let me go back out. Let me mount it again. Let's go to slash data again. We have the file. You get the point? This file is coming in from the disk, from the EBS attachment, and not from the file system directly. Okay. So this is what test cases, what I wanted you to do. I want you to perform these activities, what is mentioned here, and see if you can attach this volume even after reboot. Okay, this is one activity that we will be doing, okay, in our upcoming classes. But I want you to try it out on your machines too. Okay, I'll be sharing this link with you right away. Okay, please save this link and give it a try. Let's see if you can still sustain this mount point even after reboot or not. Okay, you can also change this file system um to other file systems that we have. Okay. uh, 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 uh. Anything else, guys? Anything in this? There is one more thing in this that I wanted you to share, that I wanted to share with you. Okay, let me unmount this. Flash disk. I'm removing this disk now. We have 3 disks. I'll see if I can modify this disk. Now I cannot make any much changes in this. All I can make changes in the size, and that will be directly applied because it doesn't require any reboot yet. Okay. Now let me detach this volume. I can detach this volume and attach it to other instance too, but together at a time I cannot attach it to 2 places. Now if I go ahead and check LSBLK, that disk is not there. I can now delete the device. Okay, I am let it detach successfully. I am deleting the volume. Once I delete the volume, my test data will be gone. My test file will be gone. Okay. But I'm okay with it because I don't have much data in there. Okay. Now I want to create another volume. But this time I want to show you something extra, which we have skipped in the first iteration. Why? Because I wanted to show you this in the second iteration. Okay. Number one, it should be in the same availability zone as your instance. So go ahead and check the availability zone of your instance too. Okay, so we'll come here, we'll check the availability zone of this instance of the subnet. It is in AP South 1A. So creating it in AP South 1A is an okay option. We don't want to use any snapshot, but there is an extra option called encryption. Amazon EBS encryption. So what happens here is usually your data resides in plain text format in your, or without encrypted, uh, your device is there. Okay, like you have attached a disk. Okay, that disk is not encrypted or something. Okay, and it is just attached there. Okay, so your files will be in bare format. Okay, bare format. It's not plain text, it's bare format. Now when I apply encryption to it, your entire volume will be encrypted. Okay, and if you lose this key, you'll lose the data. So a person who needs to decrypt the attachment will have to, or take this volume somewhere else. Example, now you want to hack this volume or you want to take this volume somewhere else. You will have to either decrypt this volume, okay, and then send it there, or you need to have this key also there and this volume also there. This encryption of volume, generally in some companies which are very restricted to security, they will attach this encryption to your uh, laptops and other things too. Okay, so I'll encrypt this volume. I can go ahead and create a custom KMS key. KMS key is the key management system. This is where all of our encryption keys will reside. Okay. I am using a default EBS key for now. Okay. This is very, very specific to this account and region. This account and region. Okay. And now I'll create the volume. This time volume that I've created is an encrypted volume. Now if you want to create a snapshot, that snapshot will, if I create a snapshot, that will also be encrypted. Okay, until and unless I decrypt the volume and then I send it somewhere else, only then that data can be transferred. Okay, so this gives you an extra layer that your data in this disk is not as a bare file. Okay, it is there in an encrypted format which will be decrypted with the KMS key that I've given just now. Okay, but apart from this, to you, apart from transferring the keys and transferring this data here and there, okay, it will no longer impact you that much. Okay, I'll show you how it is impact, how can it impact me. Okay, I'm just attaching it as SDF. Now I'm on the machine itself. I'm doing LSBLK. It is coming as same only for me. Okay, I'm doing this mkfs command. I'm setting an uh, setting the file system. Okay, after setting file system, I will simply mount this to slash data again. Okay, let me check whether what is there in the data folder. Anything there? No. Now you can still go in the data folder. You can still create your files. Everything else will remain the same, apart from the fact that this time your file system is in an encrypted format and not in the bare format. Okay, that means everything that is saved here is encrypted with the key that is shared there. Your entire file system is like that. Okay, it will not be able to write because we have to use sudo. Done. Now if you see here, you'll see that disk, you'll see the data. Let's reboot the system. Okay, next time it will still be attached, but it will no longer be mounted. So you'll have to just go ahead and remount it. Okay, and see that the file exists or not. This is all in all about EBS volumes. So these are the different things that you can do with it. Okay, you can attach it, you can reattach it, you can increase a bit of the size. You, if when you are increasing size of the root disk, what is going to be the impact, so on and so forth. Okay, now if I want to increase the size of this disk, I'll modify the volume. I'll make it to 6G. Modify. It's still in modifying state. Again, LSBLK. 6 GB. Now we'll see whether our data resides still is there or not. Our data is still there. Okay, size of this disk is increased. To check that, df-h dot, this is the command to check it. So here it is still showing 5. Now let me again do a reboot. When you'll again do a reboot, then it will successfully pick the correct size. We'll have to wait for it for some time. It will take some time for it to reboot. Okay, it just takes some time. Let's wait. You can reboot it from here too. Okay, you can just click on this instance, reboot instance. Okay, I am doing it from via command line. Again, lsblk. Okay, mount cd/data vim test sudo. That's when we'll be able to read it. We are able to read it now. And next thing is size. Check the size. Now it's showing size 5, available 5, and use this much. Ideally, it should be 6. But it's anyways more than 6. Okay. So this is how EBS volume works. Second thing that I wanted to discuss today was EFS. Okay. But I want to start it fresh tomorrow so that we can understand EFS volumes in depth again. Okay. But today, simple topics that we have covered, very, very simple topics that we have covered is how to create a volume, how to attach a volume, why would somebody do that, okay, and what is the use case of this, what are the advantages, and how to increase a volume, decrease a volume, and mount a volume. Okay, very simple topics. Tomorrow we'll be learning about EFS, that is elastic file storage. Okay, this is uh, expandable, storable. This is used when you have to use one disk and attaching it to multiple locations, multiple places, and see and like and put data there, or it is consuming data from there. It is very, very similar to the native NFS systems. Okay, anything else?